In this lesson, we will learn about SI units, what they are and why they are super important. We will also explore SI units of common physical quantities like area, speed, force, and momentum. Then finish with some exercises. By the end of this video, you will be able to determine SI unit for various physical quantities. For example, if the equation is Q equals mc delta t, and you want to know the SI unit of this C, you can find it. Here is a picture of a man who is 6 feet tall. The word feet here is a unit of measurement. In the US, people are used to measuring height in feet, so they can easily picture how tall a 6-foot man is, even without a ruler. But other countries like Thailand, people don't really use feet, so they might not have a clear idea how tall that is. This is why, in physics, we use a standard system of measurement called SI units. This system helps everyone around the world communicate in the same way. Okay? And the SI unit of height is meter. So instead of 6 feet, in SI units, we would say he is around 1.8 meters tall. Next is about physical quantities. In physics, there are many different quantities, such as length, time, speed, and mass. These quantities can be divided into two groups, base quantities and derived quantities. The base quantities are fundamental. They cannot be broken down or expressed in terms of other quantities. On the other hand, derived quantities come from combining base quantities. For example, speed equals distance over time. Distance or length is base quantity, and time is also base quantity. When we combine these two together, we get speed, which is derived quantity. Next, we are going to learn about the SI units of base quantities. In physics, there are 7 base quantities. At the beginning, the top 3 will be used the most. Okay, let's start with the first one, length. The SI unit of length is meter, and the symbol is m. For example, this pencil is 0.15 meters long. Next, look at this picture below. The width and the length of a rectangle is also the meter. Now, look at the pictures below. The usual character is 10 meters away from the house. This shows that distance is also measured in meters. The second base quantity is time, and the SI unit of time is second, symbol S. For example, if an object moves from one place to another place in 5 seconds. Since t represents time, so we can write it as t equals 5 seconds. Next, we have mass, and its SI unit is kilograms, symbol kg. For example, a man has a mass of 60 kilograms. Since m is mass, so we can write it as m equals 60 kg. Okay, but be careful. The SI unit of mass is kilogram, not gram. Next quantity is temperature. The SI unit of temperature is Kelvin, symbol K. For example, if the temperature is 300 Kelvin, so we can write T equals 300 K. The next quantity is electric current, and its SI unit is ampere, symbol A. For example, imagine if we have an electric circuit. Here is a battery, and here is a light bulb. When the circuit is complete, the current flows through it. Suppose that current equals 0.2 ampere. Because I represents current, so we can write I equals 0.2 amps. The next quantity is amount of substance with the SI unit mole, symbol MOL. For example, this container contains 5 mole of sodium chloride. Since N represents amount of substance, we can write N equals 5 mole. And the last quantity is luminous intensity, and its SI unit is candela, symbol CD. This rectangle is 3 meters by 2 meters. What is the area of the rectangle? To find the area, use this formula. Area equals width times length. So area A equals 2 times 3, which equals 6. Questions: what is the unit of this area? And the answer is square meter. Why? Because when substituting unit of width and length, we use meters. And meters times meters give square meters. So, when multiplying quantities, the units must be also multiplied. Okay? Next, let's find the area of this blue rectangle. The area A equals 3 times 5, which equals 15, right? What is the units of this one? The unit is square inches. Why? Because this time we use inch. So inch times inch equals square inches. Next question. Is the square inch an SI unit of area? The answer is no, it's not. The SI unit of the area is square meter. So in conclusion, if you want the unit of the result to be in SI units, when substituting each quantity in the formula, you must use SI units. Next, let's calculate the volume of this box. To find the volume, we use this formula. Volume equals width times length times height. So V equals 1 times 3 times 2, which equals 6. And since we use meter for width, meters for length, and meter for height, multiplying them together gives us cubic meters. So in conclusion, the SI unit of volume is cubic meters. Now suppose this box has a mass of 18 kilograms. What is its density? To find density, use this formula. Density equals mass divided by volume. So D equals mass is 18 kilograms divided by 6 cubic meters. 18 divided by 6 equals 3. And its unit is kilogram per cubic meters. So, when dividing quantities, the units must be divided as well. And in conclusion, the SI unit of density is kilogram per cubic meters. Now, look at this picture. An object is 10 meters away from home, and it takes 5 seconds to travel back home. What is the speed of the object? To calculate speed, we use this formula. Speed equals distance over time. Since we represent speed, so V equals distance is 10 meters divided by time, which is 5 seconds. 10 divided by 5 equals 2, and the unit of this one is meter per second. So the SI unit of speed is meter per second. After studying physics for a while, you will come across the term velocity. Velocity and speed have the same SI units, which is meter per second, but there is a difference in meaning. Next formula, A equals delta V over T. A represents acceleration, V represents velocity, and T represents time. The triangle symbol here is called delta. It represents the change in a quantity. So delta V refers to the change in the velocity, which is V2 minus V1. V2 is final velocity and V1 is initial velocity. Okay? Now let's find the SI unit of acceleration. First, we need to find the SI unit of V2 minus V1. Since V2 minus V1 has the same unit as velocity, so the SI unit of V2 minus V1 is meter per second. Divided by the SI unit of T is seconds. Dividing meter per second by second gives meter per second square. So the SI unit of acceleration is meter per second square. Next equation, F equals m times A. F represents force, m represents mass, and A represents acceleration. The SI unit of mass is kilograms, and the SI unit of acceleration is meter per second square. So the SI unit of force is kilogram meter per second square. This unit is quite long, so scientists gave it a special name, Newton. Next formula, P equals m times V. P stands for momentum, m stands for mass, and V stands for velocity. The SI unit of mass is kilogram, and the SI unit of velocity is meter per second. So the SI unit of momentum is kilogram meter per second. Next formula, W equals F times S. W represents work, F represents force, and S represents distance. The SI unit of force is Newton, and the SI unit of distance is meters. So the SI unit of work is Newton times meters. The scientists also gave it a special name, joules. After you studying physics for a while, you will come across the term energy. Work and energy have the same SI unit. Next, last equation. M equals F times D. M stands for moments of force, F stands for force, and D stands for distance. The SI unit of force is Newton, and the SI unit of distance is meters. So the SI unit of moment is Newton times meters. Next, let's do some more exercises. Example number 1. From the equation Q equals mc delta T, where Q has the unit of joules, M has the unit of kilogram, and T has the unit of kelvins. Determine the SI unit of C. I will start from the equation Q equals mc delta T. Because we want to determine the SI unit of C, we need to rearrange the equation. To isolate C, we move M and delta T to the left side. So we get C equals Q over M delta T. Then substitute each variable with its SI unit. The SI unit of Q is joules, divided by the SI unit of M is kilogram. And because delta T has the same unit as T, so the SI unit of delta T is Kelvin. And the final result is joules per kilogram Kelvin. Next example, from the equation PV equals nRT, where P has the unit of Newton per square meters, V has the unit of cubic meters, N has the unit of mole, and T has the unit of Kelvin. Determine the SI unit of R. Okay, so let's start from the equation PV equals nRT. To isolate R, let's move N and T to the left side. So we get R equals PV over NT. Next, substitute each variable with its SI unit. The SI unit of P is Newton per square meter, times the SI unit of V, which is cubic meter, divided by the SI unit of N, which is mole, and the SI unit of T is Kelvin. Dividing cubic meters with square meters gives meter. So the result is Newton meter per mole Kelvin. Next example. Which unit is not SI base unit? Here is a 7 base SI unit. A represents ampere, kg represents kilograms, mole represents mole, and C actually represents coulomb, which is not in the table. So the answer is choice D. Example number 4. Which unit is an SI base unit? Here's table of the SI base unit. And the answer is ampere. Example number 5. Which of the following could have the same units as force? The SI unit of force is Newton or kilogram meter per second square. Look at choice A first. The SI unit of mass is kilogram, times the SI unit of velocity is meter per second. So the SI unit of this quantity is kilogram meter per second, which is not the same as the SI unit of force. So this choice is incorrect. Next, choice B. The SI unit of speed is meter per second, times the SI unit of time, which is seconds. Second and second cancel each other out, leaving only meters. So this one is also incorrect. Next, what is the SI unit of energy? Work and energy have the same SI unit. So the SI unit of energy is joules or Newton meter, divided by the SI unit of distance, which is meters. Meter and meter cancel each other out, leaving only Newton. So this one has the same unit as force. So the correct answer is choice C. Next example. What are the SI-based units of work? Work equals force times distance. The SI unit of force is Newton, and the SI unit of distance is meters. Since 1 Newton equals 1 kilogram meter per second square, substitute this in. We get kilogram meter per second square times meters, which is kilogram meter square per second square. So the correct answer is choice D. Example number 7. Which row show an incorrect combination of a quantity and its unit? First, look at A. The unit of time is minute, which is correct. Next, B. The unit of charge is actually coulomb, not ampere. Ampere is the SI unit of electric current, not electric charge. So the answer is B.